The last section that we're going to cover in our inequalities, we split actually into 2 days, and we're going to take a step back and do some solving multi-step equations again. A little bit of this will be review, and some of it will be new, and then we're going to take what we learn in this lesson and apply it to the day 2 lesson, where we switch back over to inequalities. So we're going to start with something where we are solving equations that have like terms on one side. So I need you to write these rules down. There will actually be 3 slides like this today, where each slide we get a little more difficult in our equation solving. So the only thing different here is the first step. And when you are solving equations that have terms that are the same or like terms on the same side, we have to combine those like terms first. After we combine the like terms, then we undo addition and subtraction, followed by undoing multiplication and division, just like in the past. So let's just look at an equation. Example. We have 2x plus 7 plus 2x equals 15. And what you should be noticing here is that we have like terms on the same side of the equation, the 2x's, and we need to combine those together. So 2x plus another 2x would actually be 4x plus 7 equals 15. Now this is a 2-step equation where we're going to subtract 7 from both sides and then divide by 4. So you get the answer x equals 2. You can check your answer by plugging that 2 in for the variable. So 2 times 2 plus 7 plus 2 times 2 should equal 15. So that's 4 plus 7 plus 4, 11 plus 4, 15. So it does check out. So again, when you have like terms on one side of an equation, you're going to combine those like terms together first before you solve the equation. Number 2, we have 2 plus 3x plus 4 plus 2x. Here we have 2 pairs of like terms. We have the positive 2 and 4. We also have the 3x and the 2x. I'm going to go ahead and combine the variables first. That's 3x plus 2x is 5x. 2 plus 4 is 6, positive 6, so it's a plus sign, equals 16. Now we go ahead and subtract 6 from both sides, and then divide by 5. So we get x equals 2 again. You could check your solution by plugging that into the original equation and making sure that the left side equals 16. And I have one more. This time we just have the variable over on the right-hand side, just looks a little different. Still the same concept. We have 2 terms over on the right-hand side that are like terms. If you have 4x's and you subtract 1 away, we're going to combine those to get 3x, and then we bring down the plus 5. And again, this is now a 2-step equation, so we're going to subtract 5 from both sides. That gives us negative 3 equals 3x. Divide both sides by 3, and you get x equals negative 1. With an equation, we're not as picky with writing the variable on the left. You're certainly welcome to do that. But with an equation, we're not graphing, so it's just x equals 1, or negative 1. Now we're going to look at some equations where we have variables on both sides. And this is where this is quite a bit different than what we were just doing. But when you're going to get the variable on the same side, you always want to move the smaller variable to the side with the bigger variable. And I'll explain why in a moment. But then it's a 2-step equation. So you can undo your addition and subtraction, and then undo your multiplication and division. So again, we're just going to look at examples. So number 4, we have 3x plus 7 equals 5x minus 9. And what you notice here we've got 3x on the left and we have 5x on the right. We need to get those terms on the same side. You move a term with a variable just like you move the +7 and the -9. You pay attention to its sign and you do the opposite. So this 3x is positive, so in order to make this 0x on this side, I need to subtract 3x from both sides. And you'll notice that I strategically put it right underneath the 5x because that's the term I have to subtract it from. It doesn't make any sense to take the 9 and subtract 3x because those are not like terms. So I'm going to purposely put it underneath the x term. So on the left-hand side, those x's cancel out and I bring down the 7. Over on the right, though, I have 5x minus 3x. So that's 2x, and I bring down the -9. Now again, we're back to a two-step equation, so we're adding 9 to both sides first. We're undoing the subtraction by adding. 16 equals 2x. Divide both sides by 2, and we get x equals 8. If you want to check your solution, we're going to plug that 8 in for the variable on both sides. 3 times 8 is 24. 24 plus 7 is 31. Here we have 5 times 8 is 40. 40 minus 9 is also 31. So we have a true statement. We know that our answer, x equals 8, is correct. Number 5 is 6x plus 3 equals 8x minus 21. So again, we have 6x and 8x. And in the notes slide about the steps, or the rules, I mentioned that we want to keep or move the smaller variable. 6 is smaller than 8, so I like to subtract the 6 to the other side. The reason why I like to do that is because then we don't end up with a negative in front of our variable. And when we switch back to inequalities, you know that having a negative in front of the variable means there has to be a sign flip somewhere. So this way we don't forget because we don't have to do it. So the 6x's cancel. I bring down the 3. 8x minus 6x is 2x minus 21. We're going to add 21 to both sides. 24 equals 2x. Divide both sides by 2. X equals 12. And again, you can check the answer if you like. On number 6 now we have what looks to be quite a mess. We have distributive property. I can see n's on both sides of the equations. So the first thing you always have to do is distribute. And if we go back and look at the rules, it says to get the variables on the same side by moving the smaller variable to the side with the bigger variable, but you have to actually distribute first. So when we distribute first, excuse me, you get 5n minus 15 equals 3n plus 21. Now we're going to move the 3n to both sides. It's going to give us 2n minus 15 equals 21. Add 15 to both sides. Undoing that subtraction before we undo division. 21 plus 15 is 36. Divide both sides by 2, and we get n equals 18. So if you have the distributive property, and you're going to see that on the next slide, but if you have the distributive property, you always want to do that first, because after you distribute, you might have like terms to combine, you might have variables on opposite sides of the equation. So now it's our final set of rules. Multi-step equations, as complicated as it gets. Distributive property, like terms, variables on both sides, all kinds of things. This is the order that we want to follow. First we want to distribute, then combine like terms. Then get your variable on the same side if it's not already. finally, when it's then a two-step equation, we undo addition and subtraction and undo multiplication and division. So I know it seems like you've written this 3 times now, but every time you're kind of adding this new step of, okay, where do I really start when this gets more complicated? So number 7, solve the equation. I don't have the distributive property, but I do have like terms, and I actually have them on both sides of the equation. On the left side, I have 2x and 5x, so that becomes 7x plus 4. On the right side, I have 24 plus 8, which becomes 32. Now you have a two-step equation because there are not variables on both sides. There's only variable on one side. So now we go ahead and undo the addition by subtracting 4. That's 7x equals 28. Divide both sides by 7, and we get x equals 4. Number 8, I don't see again a distributive property. We do have like terms on the left, 5x plus 3x. Be careful, remember that this subtraction sign goes with the constant 3, not with the 3x. So if we have 5x and 3x, that's 8x, and I bring down the minus 3. And I'm going to go ahead and bring down everything from the right-hand side. I don't have anything to combine there. I can't add the 15 with the 5x because they're not like terms. Now I have variables on both sides, so I have to take care of that next. And I move the smaller variable, so I subtract 5x to get that to cancel. So we have 3x minus 3 equals 15. Now we don't have distributive property. We've combined like terms. We've moved the variable to one side. Now it's a two-step equation. We're going to add 3 to both sides and divide by 3. So we get x equals 6. The last example I intentionally put up here, this one's really complicated. What I'd like you to do is try to pause the video and see if you can't get some of this on your own. You really need to be careful here with your signs, particularly when you're distributing. So again, pause the video and try this one on your own. So as I look at number 9, I do see the distributive property over on the right-hand side, so I'm going to go ahead and take care of that first. When I do the distributive property, I keep everything else the same. So now I'm doing negative 5 times 7, so that's minus 35 or negative 35. I have a negative 5 times the negative 2a, so a negative times a negative is going to give me a positive 10a. After I've distributed, my next step is always to combine my like terms, and I have like terms on both sides. So on the left-hand side, I have a 4, but minus 6a plus 4a, that's minus 2a or a negative 2a. If you have a negative 6 and you add 4, you're at negative 2. On the right-hand side, negative 1 minus 35 is negative 36 plus 10a. So I've distributed and I've combined like terms. Now I want to move the variables to the same side. So I have a minus 2x and a positive 10. Hopefully you'll agree that the negative 2a or the minus 2a is smaller. So I want to add 2a to both sides. It's going to give me 4 equals negative 36 plus 12a. I'm going to add 36 to both sides. And we get 40 equals 12a. And now I need to divide both sides by 12. You'll notice here that 12 doesn't go into 40, but that's okay. We're going to reduce. Let's see. They're both divisible by 4. So that's 10/3. Or if you write it as a mixed number, 3 1/3. In class, we'll work on a worksheet where we are solving these multi-step equations. And that's before we learn how to solve the multi-step inequalities. Oftentimes I think it's easier to start with equations and learn the rules and practice there, and then move over to the inequalities.